So now we will compare and contrast standard form and vertex form. Inside your notes, when you have them right way up, the top one is vertex form. So we'll do that one first. Here I have an equation, y equals half x plus 4 squared minus 2. When I compare this to the standard form equation, which is y equals a, and in the parentheses, I write x minus h. This is squared plus k. If I compare those, then I could say from this equation that I'm about to graph and describe, a is half and h is -4. And that's because when you read this equation, the sign for h is opposite from how it seems. And k is -2. You agree? Okay, proceed. I need these numbers and I need these variables identified because I'll use that information to know my vertex. My vertex is HK. So for this equation that I'm graphing, my vertex is at -4, -2. Since you can read or pull these numbers off and get your vertex very quickly, just by the way the equation is written, this is called vertex form. I'm going to go ahead and graph this. -4, -2 is here. So I plotted my point. My axis of symmetry is a vertical line that goes through the vertex. You can go ahead and draw that in. Oops. Here. This is my axis of symmetry. It's at x equals the x part of the vertex, x equals h. So for this equation, it's x equals -4. You can use the a value to determine if your graph will open up or down. Anytime a is positive, your graph opens up. Anytime it's negative, it opens down. Since a is positive half, I know that my graph will open up. What I don't know from the way this equation is formatted is where my graph will cross the y-axis. X equals 0 on the whole entire y-axis. Right? So if I want to know where my graph crosses y, I put 0 for x and I can do a calculation. My equation is y equals half. I got y equals half, parentheses, where the x is, I'll put 0, plus 4 squared minus 2. 0 plus 4 is 4. So this is 4 squared here. 4 squared is 16. So I get y equals half times 16. And then minus 2. Half of 16 is 8. So this is 8 minus 2. 8 minus 2 is 6. So my graph will cross the y-axis at 0, 6. And you can do this same process to find any points on the graph. You just substitute for the x, put in a number, and calculate and see what the y is there so you can find your points. This is what the calculator does when you put your equation into y equals and look at the table. It's doing this. So I'll draw or plot 0, 6 here. This is my y-intercept. I know where my vertex is. And I need to get points in between the vertex and this y-intercept so I can sort out what shape this is. I want to introduce another idea. This is how I usually graph them, is I use a pattern. For quadratic equations, there's a pattern for how you graph. And that works like this. So you can write this on the back, you can write it in your notebook, you can just watch and kind of see how it works. But for a regular graph that is plain old y equals x squared with no fancy updates, go ahead and put myself some marks here for points. My y-intercept or my vertex is at 0, 0. This is because if I make a t-chart for y equals x squared, whatever the x is, the y is that number squared. 0 squared is 0. If I chose x is 1, then y would be 1 squared, which is 1. I can put 1, 1 on this graph. If x is 2, then y is 2 squared. That's 4. And when I have 3, also when I have negative 3 squared is 9. So I got 3, 9, 5, 6, 7, 8, 9 here. And this is symmetrical, so I can put the mirrors of these points on the other side and draw in my quadratic curve. This is y equals x squared. Here's the pattern. For each time I drew a new point, I went to the right 1. When I go right 1 to the next point, I go up 1. Then I go right 1 again, and I go up 3. And I go right 1, and I go up 5. And you would find if you kept graphing these, that these, I call it steps, will continue to go up, counting by odd numbers. So 1, 3, 5, 7, 9, 11, 13, as I continue going up. This is for when A is 1 for my original graph. If A is not 1, then this works the same way, this step pattern. I would do 1 times A, 3 times A, 5 times A, 7 times A, and so on. So this is my step pattern. This always works. So you could use this to graph equations once you know where the vertex is. And you wouldn't need a graphing calculator, and you wouldn't have to calculate the y's for the x's. So if you want to write yourself a note of how the step pattern works, I'm going to make a note on here. From my vertex, I go right 1 and up A times 1. Then I go right 1 again, and I go up, whoops, A times 3, and right 1 and up A times 5. And right and up A times 7. Well, it could be up or down. It depends on if A is positive or negative. But either way, you multiply A times 1, 3, 5, 7, 9. So let's graph this transformation from y equals x squared using the step pattern. For this equation, A is half. So to graph the rest of this curve, I would go right 1 and up half. This is a times 1. Then I would go right 1 again, and I would go up 3 times half. So that's a point at -2, 0. And then I would go right 1, and I would go up, because a is positive, 5 times half. That's 2.5. Then I would go right 1, and I would go up 7 times half, which is 3.5. And that gets me to the y-intercept I calculated. Go ahead and connect your dots, and this is the shape of half of the quadratic curve for this equation, and then it's reflected across the axis of symmetry. So I can put the reflected points on the left side and draw the rest of the curve in. Compared to the original graph, y equals x squared, which is actually over here. This graph is wider, it's compressed. So I have a vertical compression by half. That's from this. And then I have it shifts compared to 0, 0, where the vertex is for y equals x squared. My graph moves left 4 and down 2. That comes from these numbers here. So those are the transformations. Okay, this is the vertex formula. The other one that we also use is the standard form. And we did that first. A standard form equation is written in the form y equals a x squared plus bx plus c. And a is the same number for the vertex form equation as it is for the standard form equation. They both have a, and a works the same in both of them. The vertex form equation has hk, that's the vertex. The standard form equation has b and c, and that bc is not the vertex. With a standard form equation, you have to calculate the vertex. What's easy to read from this equation, though, is what your y-intercept is. The reason is, I would prefer you wrote this as 0, c, but when x is 0, that's where your graph crosses the y-axis. So I could put 0 for all the x's in my equation and find the y-intercept. And what will happen is, let's do that. Set this up to substitute. And everywhere there's an x, I'll put 0. Anything times 0 is 0. So when I do -2 times 0 squared, that's 0. And also -8 times 0 is 0. And all that's left is this -12. So when x is 0, y is -12. That's why it just said c here. That's the only number that's left, is the last number on there. I can draw my y-intercept really quickly when I have a standard form equation. It'll be 0 and whatever the c number is. A, for this equation, a is -2. So my graph will open down. It'll be an upside down one. I'll have a reflection. I'll need to calculate the axis of symmetry. I have a formula for that. Once I know what the axis of symmetry is, I can find the vertex. I'll have to calculate that for a standard form. For axis of symmetry, you use the same formula. It's x equals opposite of b divided by 2a. So whatever the b value is, we're going to change the sign. And then you divide by 2 times whatever the a number is. So my axis of symmetry, I'll have negative, and I'll put parentheses to substitute, and then I divide by 2 times a. B is -8 for this one. So I do -8 for the numerator and 2 times -2 for the denominator. Negative is positive. So I have +8 divided by 2 times -2, that'll be -4. 8 divided by -4 is -2. So my axis of symmetry is x equals -2. Make sure anytime you write the axis of symmetry, you write an equation, not just a number, because it's a line. So I need the equation. I can draw that axis of symmetry on here. It's the line where x equals -2. My vertex will be on this line. So I can use this -2 for x and calculate the y there. I could also say this is h equals -2, now that we've talked about the vertex forms equations. So I'll use -2 for x, and I need to figure out what the y is when x is -2, so that I can have my vertex, which is hk. My equation when I substitute is y equals -2 times -2 squared, because the x is -2 on the axis of symmetry. And then I have -8 times -2, that's the x, and -12. -2 times -2, that's -2 squared, that'll be +4. So I get -2 times +4, and then -8 times -2, negative times negative is positive. 8 times 2 is 16. And then I have this -12 here. There's no calculation for that. So I have -8 plus 16. This is 8 minus 12. 8 minus 12 is -4. So my vertex is -2, -4. Go ahead and draw that one in. Now that I know where my vertex is, you have a choice. You can pick another x and calculate, just like we just did. Substitute and calculate y for that x, or you can use the step pattern. We practiced substitute and calculate, so I'm going to do another example that has a step pattern. From my vertex, I would go up or down a times 1. This is -2 times 1. So I'll go right 1 and down 2 to get to my next point. Then I go right 1 and I'll go down because a is negative, negative 2 times 3, negative 6. Ooh, looks like it's bleeding, negative 6. So I'll go down 6, 1, 2, 3, 4, 5, 6, and that is my axis of symmetry, my, sorry, y-intercept that I already had. So I just kind of checked myself too. Here's my parabola, half of the parabola, and it's reflected over the axis of symmetry, so I can put in the reflected points as well and draw the rest of the curve.